I'd like to introduce Andrew, who is going to now talk to you about implementing the National Utilities Digital Twin, the NUAR project. Over to you, Andrew.
Thank you, Andre. And just, here we go. Okay. So what is NUAR? Well, NUAR stands for National Underground Asset Register. So what this is a secure cloud-based platform, and really it's going to be a service. And when it's completed, it will do three things. Firstly, asset owners such as local authorities or utility organisations that own the pipes and the wires beneath our feet, they'll be able to make data much more readily available to other organisations who are seeking to dig or excavate the ground. Secondly, organisations who want to know the location of buried pipes and wires can get that access. They can get the information more easily in one place on their phone, on their tablet, on their laptop or their computer. And lastly, when someone's digging a hole and they discovered that something underground is different to the record, that change can be recorded and it can be shared back to the utility and asset underground owners. Andre, I think you've got the control of the screen. Thank you. So why does the UK need NUAR? Why would Australia need this sort of register? Well, the answer is quite simple, because currently there's something like 4 million excavations carried out every year in the UK, and anyone that's planning to carry out one of these excavations is obliged to acquire information about the location of all the buried assets before they start their work, before they dig a hole. And right now that information is dispersed and fragmented. It's held separately by each individual asset owner, and it varies in its format and in its quality. And the process for acquiring that information can be very slow, time-consuming, and sometimes causes people to cut corners and take risks. And when you put all these factors together, they elevate the likelihood that there's going to be a utility strike, that equipment is going to break into the utility network and cause interruption. So they cause interruptions for everybody, for the road users, for the utility service users, pedestrians, local businesses, schools, and emergency services. And repairing those broken assets causes noise, pollution, and with any kind of activity construction, it also has a carbon impact as well. So ultimately, utility strikes lead to the production of unnecessary carbon. And lastly, at the end of the day, the cost of repairing those assets flows down to higher customer bills for the water, gas, and electricity and telecom, and they can flow through to higher council charges too. Next slide. So the benefits work at two levels. At the country level, there's billions of dollars worth of costs that go with all of the strikes on underground pipes and cables. But at the community level, as I mentioned before, there's reduced noise, pollution, more efficient planning of street works, and so on. Next slide. So the NUAR is a big project and it involves a lot of different organisations. So who are we working with? Well, we're working with Atkins, which is a large engineering company. We're working with one of our key customers, the Ordnance Survey, and we are providing data validation and data ingestion services. And then there's all of the asset owners and security representatives. So you'll see up the top organisations like the National Cyber Security Centre, and we of course in Australia have the equivalent, National Infrastructure Commission and so on. And all of these organisations are working together to make this system work. Next slide. Looking at the time frame, now we started this project in September 2021. Our timeline is to have a fully operational national platform available and ready by September 2024. And while that might seem a long way off, you need to bear in mind that the challenge is significant. We have more than 650 asset owners that need to be engaged with, and we need to acquire their data. And we also need to complete a system that will ingest all of that data in a repeatable and sustainable way. So we're not looking at a one-off exercise. This will have a continuous data flow through a single portal. Next slide. So this one's about key enablers, and each one of them is documentation. So the first one is the data exploration agreement. And that is an agreement between the asset owner and our consortium as the delivery partner. And that enables us to go and access the asset data and do the necessary work to find out how we're going to transform that and ingest it into the system. The second instrument is called the data ingestion specification. And that makes sure that we have the right ongoing alignment of the asset owner's source data and that we understand the model for mapping that data into the NUAR platform going forward. And then the third key enabler is the data distribution agreement. And this is an agreement between the asset owner and the UK Cabinet Office, government in other words, that allows the publishing of that data onto the NUAR platform and in the future on an ongoing basis. So 3 separate agreements or specifications. Next slide. So building a great service. So we're about 10 months into the project and we're on track and we're where we want to be. And at the end of March, we had a working version of the platform ready for user research. Next slide. So we're aiming towards 100% participation. So you can see the UK, of course. You can see England, Wales, Northern Ireland, and Scotland's in grey, but Scotland actually have a system that we're going to tap into. And we're in really good shape. We have the necessary momentum. Next slide. So I want to talk for a minute about onboarding. How do we actually engage with the user? How do we get them on board? Next slide. So our approach is that, first of all, it's obvious, but we need to start off with people who are already interested. So the 650 different asset owners, we can't deal with all of them at once. We're focusing on those ones that have actually shown an existing interest and want to move ahead with us. And we actually had some key pilot regions. London was the first one. And we connected up with some key players such as Transport for London and Thames Water. The second key thing is to obtain senior sponsorship within those organisations early. And this is critical to unlock the doors at an operational level. And the final component was to have the Geospatial Commission and the Greater London Authority doing promotional work for the system. Next slide. So I just wanted to show a couple of quotes from the feedback that we're getting from the asset owners that are supplying data into NUAR. And one, for instance, is we would use this tomorrow if it was operational. Well, it will be. It's still going to be a year or two off, but it will be operational. We needed this 10 years ago. And I just want to contrast this with something like a dial before you dig, because with a dial before you dig system, you're just getting unintelligent copies of data, PDFs, and so on. This system is about providing you with consolidated GIS data. Next slide. There have been some challenges, of course, and one of the challenges is with dealing with so many different utility organizations, there aren't a lot of standards out there. So there's different data taxonomies and formats. All of these have to be brought together. So once, for instance, if we go to telcos, once the telco data is brought in, we want to make that telco data as consistent as possible within the NUAR environment so that the actual users of the data don't have to deal with all the different formats that are involved with the way the data is actually held by the asset owners. Another big one is security concerns. There's always security concerns about who's got access to the data and what's the chance of a foreign operator or a foreign entity getting access to the data. And that's the reason that we've brought in national level government cybersecurity experts to ensure that only authorized people get access to the data and that most people are getting access to a very cut down version of the data. Next slide. So the lessons learned, not only do the asset owners have different ways of setting up data, so do the users, such as local authorities. And we also found that senior sponsorship has made the process of getting access to data so much easier. And probably number 7 is a really interesting one, and that is we're looking at data refreshes. So we get this first cut of data, and we basically take whatever data the customer or the asset owner has that they're willing to share. It doesn't matter if it's not complete. It doesn't matter if they're not willing to give us all the attribution. We at least want a first cut. And then once they're more comfortable with the process, we can go back and get more complete data, but also show them how we're cutting down the data so that not all assets are relevant. Not all attributes are relevant to the users of the data through the NUAR system. Next slide. So finally, I'm going to finish off with talking about data acquisition, actually what happens when it goes into the NUAR system. Next slide. So this gives you a quick snapshot look at the data model. So even though there's 650 different asset owners, we're banging them all together so that there's only one model for the power network, one model for the gas network, and so on. Next slide. So the data journey. First step, of course, is we need to work with the asset owner and identify which data sets are going to be valuable to go into NUAR. Second step is we extract those data sets, and that involves getting that data exploration agreement signed. Then we upload the extracted data and we go through a harmonization process with the NUAR schema. We transform and validate the data. We need to make sure that it makes sense. And we also get that data distribution agreement signed, and we get the other agreements signed as well. Next slide. So the key points there are, we want to make the barrier to entry as low as possible. We don't want people to have to do a lot of extra work to their data before we pick it up. We'll do that. We'll restructure the data. We'll reformat the data. And uploads are going to be simple and they're going to be secure. And finally, giving us the exploration agreement doesn't necessarily commit the asset owner that we will share it externally. They're not making that agreement. Well, it does give us a chance to have a look at the data and figure out whether that's going to be valuable for NUAR. Next slide. What we get when we get the data sets is not just the raw data, but it's very important to get the customer specification for the data and also to get complete metadata. And we've ended up doing this a number of times, and we've produced a shopping list to make it easier for the asset owner to understand what we want. Next slide. So metadata, all the technical contact details. We want to make sure that when we need to go back a second time and a third time, we know exactly who to speak to, and they already have the authority to pass that data over. Next slide. And the output, that we've got that data ingestion specification, which they've signed off on, and we automatically repeat the process of going back and polling for the data. Next one. So wrapping it up, what's next? These are some of the steps. We provide the ability for asset owners to refresh their data on a flexible basis as frequently as they can. And there's a dashboard so that they can see, that allows them to go back in and track and check and see when the uploads were made, what happened when the uploads were made, and have a look at our feature accounts so that they can contribute again back to that data ingestion specification. Thank you.
Hi everyone, I'm Asis Manandar, and today I'm going to explain how one spatial's positional accuracy improvement, or PAI in short, the system can be helpful for utilities industry to have accurate spatial data while you're migrating or upgrading to the new base cadastre data. So today I'll focus on how PAI can be used to generate shift vectors by comparing two datasets, sanitize the shift vectors, and apply those shift vectors to your asset data. But let me first start with what is PAI. You may have asset datasets like water network, electricity network, or even footpaths or other datasets. These datasets may be derived or probably have been derived from a reference dataset, or even relate to those reference datasets, such as a land parcel dataset or the cadastre dataset. So these reference datasets, such as cadastre or land parcel data, are improved time and again by the responsible authority because there are improvements in the technology that we use to gain the accuracy, and more accurate data sets are available. So when the reference data set is upgraded, the asset data also needs to be resynchronized so that the topology between the asset data and the reference data is maintained. So this process of updating the asset or the user data set so that it maintains the relationship with the updated base data is called positional accuracy improvement, or PAI. In OneSpatial's PAI system, we aim to improve the accuracy of the features without compromising the shape or its topology. Next slide, please. So an example of a use case for traditional PAI is when authorities perform base data improvement programs, such as Victoria's Digital Cadastre Modernization, or the DCM program. So in the DCM, the cadastre data is being improved with higher accuracy, and so the shape, or there will be changes in the shifts in the cadastre data. So this is a quote from the website, official website, and it says, if the data was created with dependence on bitmap property data, your organizational data set may need to be integrated in reference to a more spatially accurate digital cadastre in future. So this is where PAI comes in and upgrades or resynchronizes the asset data to the new cadastre data that's available. This new data set is planned to be released from late October 2022 to December 2023, and this is the information that's available in land.vic.gov.au. So in this process, the topological relationship will be maintained, and the assets or user data is migrated to match the updated base cadastre data. Next slide, please. Yep. Another example of our use case for PAI, which is different from the base data update, is you might have data sets which you have collected, and the location of those asset data may be recaptured by new technologies like GNSS or LiDAR, or even captured during asset maintenance. But during this process, you probably would be capturing the location information of only a subset of the asset data. So based on the new location or the shifts between the new and the old subset data, you can generate the shifts, and you need to apply the shift to all of your asset data. For example, you may have collected electricity pole location data from GPS. So you will now have to shift all the cables and equipments that go along the electricity pole by using a PAI system. Next slide, please. Yep. Thank you. So I've talked about PAI and mentioned shifting, but I'd like to talk about shift vectors. So shift vectors are a key component in PI process. They are sometimes also called as link vectors. They provide mapping from an identified point in the original reference to the same point in the improved reference. Here, the two references are the old and the new cadastre dataset. It is important to ensure that the shift vectors are fit for purpose. When generating the shift vectors or sanitizing them, there are some considerations that are very important to note. So some of them are the shift vectors should vary slowly, both in magnitude, in direction. They should not exhibit any random behavior. Such random behavior like can be classed as outliers and should not be used in actual shifting. And the shift vectors should not be associated with a real world change. For example, a corner of a building should not be linked to the corner of a new extension of the building. As in the image on the right. So shift vectors should not be associated with real world change. They should not be also generated. They should not be generated on real world areas where it's difficult to identify the reference points, such as road center lines. And also an important aspect is that we need to actually have zero shift vectors to lock in the positions that are correct. Next slide, please. So a PAI process can be divided into 4 stages. The first stage is generating the shift vectors. So the shift vectors are generated by comparing the two base datasets or two subset of the datasets. Generating good quality shift vectors is vital, and like poor shift vectors will result in poorly aligned datasets. So one Spatials, our PI solution has pre-built algorithms to match start and end points and generate the centroid and vertex to vertex shifts as well. The matching process includes identifying zero shifts and automatically identifying junctions as well. So that is generating the shift vectors. But let's say you already have those shift vectors. If you already have those shift vectors, the PAI process can sanitize the shift vectors for you. Once our PAI solution sanitizes the shift vectors that have been acquired from another source, so that the outliers or non-topographic shift vectors, such as the ones generated from road center lines, are removed. So our PAI will also classify the shift vectors into zero shift and also outliers. So after we have generated a sanitized shift vector dataset, we will then transform the data or the asset data based on those shift vectors. In our approach, we use an intelligent triangulation method, and this will constrain the shape and location of immutable geometries during the shift. So this results in preserving the shape and the relationship between the features. Finally, our PAI system will generate, validate and generate the report on the results. So it will analyze the source and the target datasets, and analyze the connectivity and relationship, and report if there are any significant differences. Next slide, please. Yep. So the PAI system can be can be made available through the One Data Gateway portal. I wouldn't go into much detail in One Data Gateway, but here I have a screenshot of the One Data Gateway portal for PAI, where we have four tiles, and each tile is used to perform one of the four tasks that I explained above. Next slide, please. Yep. So here I have an example where a cadastre data is updated and PAI is used to update the footpaths data. Here I've used the example of footpaths data, but this can easily be used to used or applied to any network data like electricity, underground assets, or overhead assets, water or sewage lines, or any other asset data that may depend on the cadastre dataset. So in the first screen, I have the original or the existing cadastre data in red and the footpath data, which is in blue, and we can see that they both align with each other. Next slide, please. So now in this next image, I have the two cadastre datasets, the existing red cadastre data, which is sent to the back, and the updated green cadastre dataset, which is on top. So we can see that they do not align with each other, or not. There's not a 100% perfect match. So there are changes between them. Next slide, please. Yep. So when I display the footpaths data, I can see that the footpaths data does not match with the updated cadastre data. So there are overlaps and gaps in some areas. So this can be applied to other asset data such as network or electricity or sewage lines, where they might not, where the topology may break because of this upgrade. Next slide, please. Yep. So when we pass both the cadastre datasets into the PAI system, the PAI will generate the shift vectors for us. Here we can see those small blue shift vectors that are generated on each point where it's necessary. So vertex to vertex generation, and although not visible on this screenshot, there are zero shift vectors which lock in the vertices which are not actually moved. So we've got both the shift vectors and the zero shift as well. Next slide, please. So after we generate the shift vectors, now we can apply these shift vectors into your asset data. In this example, I've used the footpaths, and it is all performed in the PAI system. And once the shift vectors are applied, we can see that the footpaths now align with the updated cadastre. So in this presentation, I'm going to talk about the Gemini CAD cleanup process. Can you move to the next slide? Slide, please. Yep. As a background on what the Gemini CAD cleanup process was we worked together with Gemini and to clean up the CAD data that they receive. Gemini receives CAD drawings from external drafters, which describe the changes to its electricity network. So these CAD drawings are drafted for human visual interpretation. For example, when the drawings are printed out in a paper and taken to field, so they are more optimized for such visual interpretation. They are not actually designed or generated for system ingestion. However, the data from these CAD drawings needs to be extracted and imported into the GI system. So in Gemini, the CAD drafters used to manually extract or draft the network data from the received CAD files into a GIS-ready CAD file. So once that standard is maintained, the newly drafted CAD file would then be used to import into the GIS system. Next slide, please. So we identified that many of the tasks required in that conversion was a time-consuming repetitive tasks, such as converting blocks or tracing over conduits or snapping lines into points or removing unnecessary features. So the conversion of one CAD drawing would usually take about 190 minutes per drawing. So depending on the size, this is an average, but it took about 190 minutes per drawing. But taking into consideration that there are around 800 underground jobs per year and an average of 10 drawings per job, we can see that there's a lot of time spent in converting that CAD drawing into a GIS-ready CAD template. There were some challenges in this project. So the drawings from different suppliers followed different standards or drawing styles. All of those standards or drawing styles needed to be organized, and so that the system can handle all of them. Identifying the ducts was a tricky issue because sometimes the ducts were drawn as polygon, but sometimes they were drawn as series of lines. And when there are multiple ducts stacked on top of each other, it was very hard for the system to identify which line was part of which duct. Similarly, the cables were represented as series of lines, but they were in places where there are ducts, the lines or the drawing for the cables were not present. That is, so we needed to connect the ends of those ducts to the cables to extend the cables. Other challenges were converting blocks representing the pits, poles, and equipments, and calculate the appropriate rotation for those blocks, and also snapping to the cables and ducts to the pits, poles, and equipments was also a challenge because sometimes it wasn't evident, or there was some snapping missed in the drawings, but it wasn't evident while looking at while visualizing it on the paper. So those were some of the challenges. Next slide, please. So we came up with an FME-based solution where Gemini receives the CAD file and the drafter performs some quick manual update to confirm the layer names and remove unnecessary layers. So after this quick check is performed, it is then fed into the FME server web app where the FME server will process the CAD files. So FME will produce the new cleaned CAD file, and that is sent to the drafter for manual quality check and update if any features is required. So there are two quick manual checks before and after the FME process as well. So after FME produces and there's manual check completed, then the AutoCAD file is loaded into GIS. So I've got some screenshots of before and after the changes. So on the left, we can see that the ducts, the cables are not connected, and they are broken by the ducts. So we have changed it so that the cables are a single line from the equipment to another equipment and follows the route of the duct. We have converted the ducts into polygon of the ducts into the line, and also converted the equipment blocks into pits, poles, or equipment as required in the GIS template. Next slide, please. Yeah, so similarly here is the demonstration where we have changed the blocks and the cables. Next slide, please. Yeah. So in this project, we engaged in two phases. First was a proof of concept where we developed a limited scope to show the automation was possible. We worked on some requirements such as converting the blocks, identified ducts and cables, and after a successful proof of concept, we went to a production version. So in the production version, we tested the workspace for multiple files and made the workspace more rigid, and then deployed to FME server. The result of this was that Gemini staff can now access a self-service FME portal to perform the CAD cleanup, and the most of the manual time-consuming task is now automated via FME, and the time taken has been significantly reduced.
Why is there a need for the GDV hub? It's important to customers because it has a benefit to a broad cohort of people. It goes to the heart of data quality assurances, allows all parties to check the created data that they have. The benefits are that you're creating an integrity and a workability. It introduces data governance to allow information to be picked up and validated and corrected to a standard. It eliminates duplication. It improves, the improvements are in the processing efficiencies that you get, customer service, quality, completeness, accuracy of data. Ultimately, allowing asset owners to manage their assets effectively and efficiently. So in summary, the challenge that we have is that land developers, local government, utilities, consultants, and other professionals associated with land development and asset management need to be able to lodge designed and as constructed information to specifications. So how did we resolve it? We resolved it by utilizing our One Integrate and One Data Gateway to create the GDV Hub SaaS. The benefits are that it is a web-based portal to allow people to lodge their plans for the validation and to perform logical corrections against the ASPEC requirements. The SaaS will provide a platform for further development of validations to other services in good time. The challenges that we had with this was the fact that there are 7 disciplines within the ASPEC standard. The fact that we have different data formats, shapefiles, map info, geo package, which are supported. And these need to be supported across the board, if you like. So I won't go into it in too much detail in that regard. So the features of our application is that it is a cloud-based application. It provides validation and logical corrections. The data can be lodged in shapefile, MIF-MID, or GeoPackage. The user does not need to have any lodging expertise or experience. Its support for previous and current versions of standards are going to be available. It has a user-friendly interface for dragging and dropping, or you can navigate to where files are, and we'll see this in a bit more as I go through. And the other thing is it will automatically determine the discipline that has been lodged from the ASPEC. The benefits are that you pay as you lodge. The dashboard information shows you how it measures, and there's no need to purchase additional software. And auto correction is also available as a premium, and we are able to map our assets. The outcomes, we have the ability to have data validation. We have the ability to do data corrections on logical, and we can also save our schema mappings that we do, which I'll show you. So what we have is front end where we can go onto our website, and we go in and register ourselves, and we can go and utilize the system. Once we are in, we have a number of assignment pages that are available. So you can see here we've got corrections and validation tabs for assignments for the GDV hub for GeoPackage, MIF-MID, and also shapefile. Once you go in, your validation page is shown here, and you can see that there's a number of, you go to start a new, you can see your assignments that you have done previously. You can also go in and do a new submission. So you press start and away you go. And it will then run a submission for validation, showing you where you have passed and where the data is failing, and it will provide you with a view and also with a written report on where your problems are, so that you can go correct your information and then do a resubmission. But what I'd like to do is talk about the auto correction or logical correction tab. So if we go into this, I'm just going to quickly run it. We can click on our correction, start a new submission, navigate to or drop the data file that we have that we want to, and this is going to auto correct that data. We then press the continue button, and away it goes, and it uploads that data file onto the system. And now you can see that we can actually flip our source and our target classes. So our source is what we've done, and our target is what the system needs. And as you can see, it's highlighting there that the area extent hasn't been matched properly, so we are going to match it. Whoops, I've made a bit of a mistake there. I'm actually going to put that back to head wall, but there's problems with the attributes. And as you can see, there's attributes missing. So we go in and associate them so that we have got that mapped, and we can go through quite quickly. It automatically detects them, making life easier. And the beauty of it is that we've now done that. And what it is that that's what we've done in the field with our field collection, and this is what's required. So I can now save this schema mapping for future use. So you can give them different names for different people, depending on how they go and collect it, or just have one corporate. And then you can use that again and again. So we then go continue, and it's now processing that file, auto-correcting it for any of errors that have been encountered using our OneIntegrate's business rules. And it will soon have finished, and then we say go continue. It has done the process. We continue. It's now calculating our submission results, and we've now got a corrected file. We can press the output, and that will now create our file that we can then lodge to the referral authority, or the referral authority can get that to then put into their GIS system. We can also produce our report, generate a PDF, show the validated data, which can go along with the file, etc., for the receiving authority to be confident that it has been passed by the validation and correction of the GDV hub, and we can then continue on. So the schema mapping, just very quickly, as we showed, you can match it to what you need. We can save it, but we've also got the ability to have a report for our schema mapping where it will show us where we've got missing classes. It's got excessive classes. It shows us where we've got invalid classes and why they're invalid. As you can see here, we've got attributes that are missing in these regards. So you can actually get a report to show that. The other beautiful part of the GDV hub is that from a referral authority's perspective, or from within a large organization, you've got a dashboard that's showing how people's are performing, what rules are being violated most frequently, when files have been lodged, how successful they've been. From a referral authority's point of view, you can then judge which organization is doing a lot of submissions, getting the same mistakes or same violations, and from that then go and assist them in ensuring that their data is of a more higher quality, etc., etc. You're free to go to the website www.gdvhub.com, and you can register yourself and have access to this, and it is at the moment free of charge for people to use. And I'd like to also highlight that GISA Forum for 2022 will be held from the end of this month or next week onwards, and covering the various disciplines. It is free of charge, so please hook on, go to the website, register yourself for free tickets. We will be at the showcase on the 5th of October, where we'll be covering a lot more about the OneSpatial offerings.